Hello everyone. Let's continue our discussion with aggregation operators in SQL Server. There are two types of aggregates, stream and hash aggregates. Important points about these operators are stream aggregate often require data to be sorted. If data is not sorted, SQL Server might add sort operator, which might be performance costly, okay? If you do sort operations, it might cause performance issue in your server. Second aggregate is hash aggregate. This requires hashing and hash table to be built in memory. If you do not have enough memory for hashing, TempDB spill might happen. Let me show you this with real examples. Let's run this query. What is happening here? First, we are bringing all the data by using index scan. As you can see, we are reading all 504 rows. After bringing the rows, what stream aggregate is doing is, it is firstly counting the number of rows, then summing all list price. Then, in the compute scalar operator, calculating average by dividing sum by count. Very straightforward, right? Now, let's see the case when sorting is needed. For this, we just need to calculate average price by specific group, for example, size. As you can see here, after getting the list price and size columns, we are sorting it based on the size. Then, grouping by size, we are calculating count star, right? And sum for each group. Finally, in compute scalar, we are dividing sum by count and calculating average for each group. Let me show you with a simple example, okay? Here, we are getting all the data, suppose, then sorting by size, and for each group we are calculating count and sum. Finally, we are calculating average by dividing sum by count for each group and giving it to user. Very much straightforward, right? Now you understand how these operators work. I want to point out one thing here. As you can see, sort operation is additional work here. For big databases, these operations might be time-consuming and often lead to performance degradation because we should do sorting. So, what is a way to omit this operator and make the process faster? One way is creating non-clustered index for size by including list price. Let's try this. So, we create non-clustered index by including list price. Okay, then we run against the select. Here you can see now SQL Server is using created index where data is already sorted on size. Therefore, we don't need sort operation here. As a result, our query is becoming much faster without any sorting. There is another way to omit sort operator, which is another hash aggregate, okay? Hash aggregate is similar to stream aggregate, but difference is hash aggregate is for unsorted data. There is no need to sort data in the case of hash aggregate. The query optimizer can select a hash aggregate operator for big tables where the data is not sorted. Let me show you. First, we run this query. Select first name, something, right? You can see in this case, instead of stream aggregate, we are using hash match aggregate. First, we are bringing first name column data from non-clustered index by using scanning. Here, data is sorted by last name and then first name. Therefore, since data is not sorted by first name, SQL Server is using hash match. What happens if we query by last name instead of first name? What do you think? Here now, operator is changing to stream aggregate, right? Why? Because data we are bringing is already sorted by last name. For the sorted data, stream aggregate is much more efficient. Now, let's go back to hash match again. Here, what we are doing is, by using first name as hash keys, we created hash table. Then, we are running count for each group in hash table by using scalar operation. Let me show you in this way. First, we are bringing unsorted first name column. Then by making each row as a key, we are creating hash table. Then we are running count for each bucket in hash table. Very much straightforward, right? Let's explore more. Here, why SQL Server is not using sort plus stream aggregate? If we want, we can enforce stream aggregate by using hint like this. Why SQL Server is using hash? The main reason is hash aggregate here is much faster. You can easily compare here with elapsed time. You can see with hashing it is much faster. Let's try to create non-clustered index for first name and sort the data. As a result, sorting becomes not needed, right? Let's compare again. We do not pay attention to sort query as this is related to index creation. As you can see, anyway, with hash aggregate, it is much faster even though we omit sort operation. From here, we can conclude that sometimes creating index can also make the performance worse. Therefore, we should be careful while creating index. Great learning, right? So, as a conclusion, I can say for big data, hashing is much more appropriate. Okay? But for sorted, a little bit less data, stream aggregate is much more preferable. Happy learning!